Hello friends, welcome to my channel Go Digit. Today in this video we will try to understand the concept of clustered index with respect to Business Central. So as we all are working in the Business Central and I believe in your day-to-day life you must have heard about the terms like uh, performance, speed, indexes, right? So what exactly they are and how they impact our development in AL extensions, if I would say, or how the user basically when work on the web client, if they facing any issue with respect to accessing the data regarding the speed, all these concerns. So all this basically lies at the back end, which is the database, right? So for the AL developers, we generally do not go into the database thing. We generally develop at the front end only. However, it is very important to understand that how the SQL server basically handles the data inside the database based on the AL extensions we are developing, right? So the concept of clustered index is not basically, if I would say, the full-fledged business central concept, but it's a SQL server or database concept, right? So let's understand this thing. So in this today's agenda, what we will going to learn is that basically what exactly the cluster index is, how we can create the one in the AL language with the AL code, how it will look in the SSMS SQL Server Management Studio, then what exactly the catch inside it, and how the solution can be made for the problem as I mentioned here in this the catch. Okay, so let's see the cluster index. So as you can see, basically clustered index and non-clustered index. There are two types of indexes present in the table or in the database, I would say. Uh, my like what I would do is that I'm going to explain about the clustered index only in this video. I will not cover the non-clustered index part. So as you can see from the definition, cluster index is nothing but it's a dictionary, right? You have, I believe all of you have seen a dictionary, English dictionary or any language dictionary, which you, if in case you're learning any language at the moment. So dictionary is nothing but where the data is physically sorted, right? If you see that if I talk about the English dictionary, it has the words will be starting from A, then even the A, with the A, all the words which are starting with the A, it will be in a sorted order, then B, then C, then D, and so on. So it is quite easy for you if you are searching for any particular word, that if how like with which letter it is starting, then you don't have to check every page of the dictionary, right? You just have to go to that particular page only from where that word from that letter words are starting, right? So cluster index is the same thing where the data is physically sorted on the disk by the index key, right? Index key means the letter like A, B, C, D, and so on. And the catch here is that a table can have only one cluster index, which means you cannot create multiple indexes, clustered indexes, I would say. However, when we move to the non-cluster index, it is like a textbook index. So all of you have the books. You if you look at your books, it has also the index, right? But that index does not contain the data, just like the dictionary, right? It is a separate list which points to the data location, which means that if you're searching for any particular word or any particular chapter of the book, or then it has the mention that this concept is available at page number 12. So you have to first search that which page contains that data, and then when it you get the point that it is pointing to which location, so it is pointing to the data location, so you will open the page number 12 and then you will see the data. So in one way it is also faster, because if you are reading a book of 500 pages, and if you do not know that what concept which you're searching for is lies on which page, and if the textbook does not contain that index, then it is very difficult for you. to search for all the 500 pages one by one, right? And the thing is that a table can have many non-clustered indexes, right? So it is not like cluster index which will be having only one. So let's talk about further how it is created in Business Central. So let's see this, like how we can create this in the AL code, what exactly the concept is saying, and the demo type. Okay, so here the thing is, I have created one basically table and the page of it. Okay, so you can see here that in this particular table I have created four fields like number, name, address, phone number, and so on. But when you are creating a table and when you look at the keys section, so this key section is actually responsible for the concept of clustered and non-clustered indexes in SQL Server. Right. So as we have learned about previously in the previous slide that clustered index will be only one in a table. So whenever we will create a primary key of the table, the clustered, there's a property called clustered is equal to true, which basically, as you can see, it sets a value that indicates whether the key also defines a clustered index in the database. By default, the primary key is configured as the clustered key. So this is the catch here, that as soon as you create a primary key, and because we know that primary key is a mandatory thing into your table, so when you create a primary key, automatically it will be considered as a clustered index field, right? So you don't have to explicitly write any particular code in the AL language in the Business Central, uh, or define any other things. You just have to define the primary key, and this property, as it will automatically turn to true whether you define it. If you don't define it also, then also system will always consider it as a clustered is equal to true, which means that it will create a clustered index into the SQL Server, right? Now, when you publish this extension, okay, into the Business Central, then how it will look? Okay, so let's open the SQL Server Management Studio. We will try to understand about these queries as well, but if I show you the databases and this database, this table, okay, so although we can filter, but I can just like to show you that how the tables are looking at the backend if you have never seen this before. Okay, so here the thing is, you can see that all the tables of Business Central are currently listed based on if you have the table per company or without per company, right? So as you can see, my table name starts with the clustered index, so we will be looking after for the cluster index thing. I can filter out, I'm again saying, so maybe some of you will might comment that you can use the filter option, but let's see this. Okay, here it is. So this is my table, right? So when you expand this particular table, you will see the list of columns, keys, constraint, triggers, and the indexes. So this is what we are looking for. So first of all, let me show you the keys. It has two keys, and if I show you the columns, it has so many columns, you can see here. Although when I showed you the table, it has only number, name, address, phone number. However, at the backend in the database end, SQL by default creates these fields as well, which will be uniquely identifying your records, your data inside the table. So you don't have to be worried about, because you don't have to handle it manually. System will be handling it automatically for you. But uh, the keys are, this is our pk, which is our primary key, which is belongs to the number field. As you can see from here, pk in not null, which is number. And this is, as I suggested, this is a system handling field, so you don't have to worry about it. Now when you create this primary key, automatically into this index section, you will be having the new cluster index created for you, right? And by default, one non-cluster index related to the system id field also gets created, which we have not created at all. Okay, so now the thing is, as I told you, that basically if at the back end, this gets created automatically when we create the primary key. Now what I can do is that we can see the properties also for it. uh, let's see the properties. So here you can see that what it is saying. It is saying that it is defined on the number field. It will be sorting always in the ascending order, right? It will be always not null. And further things is that if I show you one options, mm, not this, storage section. Yeah. Okay, so pages, if you look at this property or this pages, so basically the data, when the table which is, you can see here in the SQL server, uh, it contains the data, but basically at the SQL also, this data is getting stored at the page level, right? The page is a unit which is of, if I could say the size, it is of 8 KB. So if even if your tables have millions of records, it will be divided into pages, and each page can contain maximum of 8 KB data. So based on the size of your table, it will divide into multiple pages, and you can see that how many pages are there for your particular table, and based on the number of records inside it. And that is how, because the data is divided into the pages, so clustered index will help you in searching not the all pages, but with respect to the particular page in which your data lies. Okay, so this is how it will look into this SQL server. I don't know why my system got hanged. Yeah. Okay, so let's see the benefit part of it as well, that how it will basically help in when the cluster index is available. Okay, so let's see again. I showed you already this, how it looks in SSMS, right? Database, tables, keys, and the proof is like, it will say clustered also, and the demo time I already showed you. Okay, so the benefits, like why we are creating, or why the system is automatically creating the cluster index. Basically, as I told you in the example also of dictionary and the textbook, that when you have millions of records, when you have millions of pages, then it is very difficult to manually search for your data. But if you have the index, you can directly pinpoint to that particular location. So it has this concept of index seek and index scan. Okay, so whether you're searching for any particular range, or whether you're searching for any particular number, it can, SQL Server inside has this tool which will look after that how much cost it will to search for, whether they have to proceed for the index scan, whether they have to proceed for the index seek, or the complete table scan, right? Scanning means like, so checking for the data, the complete table, the complete index, or directly pinpoint to the location. Okay, so you can see here that select where number 20,000 or 10,000 and 20,000. So all are very very fast. Okay, sometimes I have seen that even it also goes inside the seek only. I will show you in the SQL server. Okay, so before we come into this, let's see the SQL server. So here, as you can see, that I have basically written this first query. If I run this first query for you, execute, looks like there is some problem. Let me delete this. Select star from clustered strange. Okay, sorry, my bad. I'm not connected to my database, so this is my database. Perfect. So now let's see this first one. In this query, I am just basically wants to run the entire table record. Okay, so this table, as I have already created in the business central, and I have created somewhere 100 records. So let me open this one as well, and let's run this. So you can see here in the results section, I have got the data. I have created somewhere 100 records into the table, and it is showing me all the 100 records, all the fields data. But if I show you this field, live query statistics, so here it is telling me that it is running clustered index scanning. Okay, which means that if you look at this data, it is saying actual number of rows for all execution is 100, actual number of rows read also 100. But the thing is, it is not going for the entire table scan, but it is searching for cluster index only. Okay, so this is how it is fetching the data from the index now and not from the table. So when you run this first query, uh, let's run this also. If I am looking for only number and name and not any other fields of the table, so whether it is will be doing the stuff for, you can see here that it is also currently running index scanning only, clustered index scanning only. It is not giving me index key, seek, or other things. Okay, but now here the catches. If you look at here, so here what I'm doing is that I am adding one filter, which is where number is equal to 10. And when now I will run this, here you will see the difference. It is now not scanning the entire table or entire clustered index, but it is checking the index seek. So these index seek or index scan are basically the execution plan. So index seek, as I told you before, it is very faster, instantaneous. So here, if you look at these two properties, actual number of rows read 1, actual number of rows for all execution is also 1, which means that it is now not searching all the 100 records inside your table. It is checking only one record. And you know, checking 100 records is obviously slower than checking only one record. So how optimize this query now when you are just looking for only one data? So SQL do not have to check the complete millions of records. It just have to go into that one particular record. And this all is happening because of this number field, which is a primary key and which is a part of clustered index. And as we told you that when we prepare the cluster index inside a table, it will physically sort the data, right, and creates the data in the pages, and that's how it will check that now I don't need the complete index scan, but I need the index seek only. Okay, so this is similar to when we write the get statement in our AL code, like customer dot get 10,000. So you can understand that why we are saying the get function is so faster, because it will at the backend goes with the index seek function for the cluster index. Okay, now let's see this second query as well. So here I am checking that I am looking after only for the records between 10 and 50. So still I am looking for a range, not for the whole data. Let's see how what it will give me. And you will be good to see that now again SQL is deciding that I would go for index seek, where again I have to look for only 41 records only out of 100. I don't have to search for all the 100 records. And this is again very faster, because in terms of checking 100 records is always be slower than checking the 41 records which the user is looking for. So if you see here, what you will get remind of if you are an AL developer, that the kind of function we use there, the like set range, set filter, so that will be also very faster. Probably only the thing is that you have to add that particular field which will be a part of the index, right? If you have multiple fields inside a table, and if you are adding a set range or a set filter for any other field which is not the part of clustered index or non-clustered index, then obviously it will be slower. So this is how let me show you one more thing, that this phone number is not a part of uh, any basically uh, cluster index or non-cluster index at the moment, right? Although this phone number, if I want, I can create a secondary key and it will be treated as a non-cluster index. But let me run this one for you first. So here you can see it is checking index scanning. Okay, but the point is it is reading all the 100 records this time, right? When we you can see here that it is r- reading all the 100 records, and out of the 100 records it is getting only one record for us, because obviously we are looking for only one record. But the point here is it is slower comparatively to the uh, to this query, because here if you look at this, it is also cluster index, it is seek, right? Because it has this field which is a part of cluster index. So it is index seek, but it is index scanning, because this field is not a part. So it has to read all the 100 records, right? So this is how the what exactly the problem with respect to the other fields. So when you use the functions like set range, set filter, and adding the fields which are not a part of an index, then maybe the performance will be slower comparatively to the index fields. So how we can adjust, because primary key we can create only one primary key, maybe you can add multiple fields inside it, but that's a secondary case. You cannot make all the fields of the table a primary key. So that's where the non-clustered index concept comes into the picture, right? And how we can create the same is that we just have to add uh, another key, which is will be the secondary key, right? So here, like if I create like this, cluster by default is false. As I told you, cluster will always be one only. Okay, you don't have to define it also. So now when you compile the project, and let me try to publish this as well. So you will see now that phone number will become a part of non-clustered. I will show you that. And when we run that query now, it will be uh, not running for cluster index, but it will be running for non-cluster index. But the catch here is that non-cluster index does not contain the data or into it, but it points to the location. So basically first it will check the non-cluster index, get the number of get that on which page this exists, and it will route it to the cluster index. Okay, so my extension is published. Let me refresh whether now I get to see one more index. Still not showing. Let me reconnect. Okay, and this time let me add the filter. Name contains clustered. Okay, so here this is my table, whether you, which is available in two different companies. Let me show you this one. Now let's see the keys and the indexes. So here you can see that non-cluster index for the phone number field is gets created, right? So now when this index gets created, let's get back to our slide, and we will try to understand this one. So what exactly the catch is, that why inserts are slow. So we have seen that reading the records, fetching the records is faster, but there is one problem here with the indexes is that inserts or modification become little slower, right? So the thing is that why it is slower. Let's see this. There's a problem called page split problem, and what exactly this problem is that, because we have understood with an example of dictionary. So what it is saying here is that, what if you have to add banana to a dictionary that has apple and ball already? Okay, so in our case, like if I have to, just a second. So if I have to execute this, and we can see the results that it has 100 records, right? Let's say if I will create 102 and skip the 101, and then I have to, after creating 102 record, I have to create 101 record. So which means that system has to SQL has to recreate, like system has to create the data between 100 and 102. And then because it is not in a sequential manner, then SQL has to rearrange the index, because as we have learned that in the cluster index, data is always will be in a sorted order. So sorted order will always gets be available when it has to rearrange, otherwise it will get disturbed. So that is how what happened basically when it has to create the data. uh, any new data or any modification happens, then at the back end, SQL runs these functions as well, right? Rebuild, reorganize, and these type of things. So basically, it always gets updated. Index has to always update itself based on the new data or the modification happening in the data of the table, and this basically turns the system a little bit slow. Okay, so that's why what we are saying, that you can't add it to the end, you must make a room in the B section. So same manner, SQL must do the same, forcing the data to move and split the pages. So this is very slow operation, right? So how to handle this? This is a performance summary. Basically, like we have learned this select query with the primary key, which is very faster because of index seek. Range is also faster, physically sorted. Insert and updation, I explained you the problem is that because SQL has to move the data in between, and that's how rearranging the index again and again based on every modification, every insertion into the table. So that this makes a little bit slow from the performance side. So how to make these inserts operations faster? Last part. So it depends on the keys, right? So always it is good that whenever you are creating a primary key, it has to be it has to contain a sequential way data, right? It should not be like GUID field or any name field or any description field, because name and description like text, these things are very difficult to maintain sequentially, right? uh, because someone has the name AA or A or BB or something like that, right? So it is very difficult. However, when it is a sequential, a number way, integer number field, which is very easy to handle, like 1 2 3 4 5 6 7 8 9 in a sequence, right? So that's why if you see even in the business center also, so generally the primary keys of the table are always like number field, entry number field in the ledgers, and so on, because then it easy for the SQL, for the business central to maintain your data, to rerun the indexes faster way, or inserting the data in a sequential order. It does not have to create the data in between of the already existing records, right? Integer field, when you create big integer field like a number series logic, then this makes all inserts an append only operation at the end of the table. So no page split is basically required. Okay. In business central, automatic bulk insert concept, if you have heard about, so this also be very helpful automatically. We don't have to do it any manual code for it. So for example, if you look at this, what it is saying, slow code, if you write any condition like uh, inside the loop you are creating 100 of records. Okay, so if you add if operation, if word, then it becomes very slower, because for this you have SQL have to navigate per record, or have to trip every time in a record, in a loop, every one time it has to go to the backend to insert manually. However, like if you look at this code, for I is equal to 1 to 10,000, my record dot insert. So at this time, because there is no if condition, server not going to the like SQL is not tripping for per record. It is automatically buffering the entire loop. For 10,000, it will buffer everything, and only once this operation gets finished, and when you write my record dot insert, like finally when this loop gets end, then only automatically it will bulk insert the data inside the SQL server, because uh, of faster insertion. Otherwise it will be very slow, right? So this also is automatic in the business center, so we don't have to worry about. Solution number three is minimizing the keys. So although we have learned about that, it is good to have the indexes for the faster retrieval of data. However, it is not like that, okay, if you have 100 fields inside your table, you will create the 100 indexes for your table as well, right? So it is very important to design your table, to design your field in such a way that uh, you have to add only those fields to a part of the keys which you will always be playing with, right? With respect to your code or any searching or any filtering. So you have to add those fields a part of indexes, so that you will be having minimize keys, minimum clustered indexes on sorry, non-clustered indexes, and then SQL will have to do less operations of rebuilding and reorganizing your indexes whenever any new insertion or modification happens. Okay, so what we have learned here is that the cluster index is the physical sorting of your table, just like dictionary. In Business Central, the primary key is basically equivalent to the cluster index. It makes select query extremely fast. There are some problems which is called page split whenever any insert or modification operations happens. However, When you use sequential keys like entry number or number for high volume tables like ledger entries table, it is very impactful. And bulk insert is basically is a part of business central only, which our system automatically handles, so we don't have to do worry about this thing. And of course the minimize indexes, minimum number of keys which you will create as a table, that is very faster, right? So I believe this is the whole concept which I wanted to explain in today's video about cluster index, non-cluster index, how they are faster, what are the problems, what are the solutions. So if you already know about this concept, this is very good. I believe your extensions are already behaving like not creating any performance issues for your customers. But in case you did not know about this concept before, then I believe you should now, from now onwards, whenever design any new table, keep this information with yourself, so that uh, you design your table in a very good manner with the actual fields become a part of the keys which you always use in your code unit functions to process, to fetch the data from the table, right? So that's it in today's video. I hope you like it. In case you like it, please hit the like button and please subscribe to my channel. Thank you so much for watching this video.